Hello class, welcome to our first lesson dealing with section 3.3. This is where the idea of the unit circle is introduced in this textbook. I'm going to plan to try to use the triangles and things like that to help explain what the answers are. If you're curious about how the unit circle itself works, which some of you have known that in the past, or if you would like to know how it solves things, you can find a quick YouTube video or there's lots of information online that deal with the unit circle. I tend to use less of the unit circle and more of other methods because the unit circle really is a device that works in certain cases and maybe not as well in other cases when you don't have these nice exact values to look at. But in general, we'll still be using some of those things in order to find answers as we go through this lesson. Okay, the first group of problems, the key wording is going to be exact value. So if you see something that says exact value, that's probably a 30, 60, 90 idea, going around the circle, figure out what quadrant, what triangle is used, etc., etc. Okay, those are the types of ideas that you want to think about when it comes to exact value. The answer should be reduced to a fraction. You're going to have radicals that are rationalized, for example, from a denominator standpoint. So I'm just going to highlight a few things on some of these. This is that same information again. For example, 5 pi over 3. Pi over 3 is 60. Times 5 would be 300, so it's quadrant 4. You just find cosine of the reference angle, which would be 1/2 in this case, because across or adjacent to 60 is 1 and hypotenuse is 2. It's positive because it's in quadrant 4 for cosine. 3 pi over 4. Pi over 4 is 45. Times 3 would be 135. That's quadrant 2. Remember, to find secant, using SOHCAHTOA, I can find cosine and then flip it. So cosine would be 1 over root 2, and then I flip it and be negative root 2 simplified down. Don't forget about negative signs. I've noticed on some assessments that some people are not even looking at the negative signs for the angle. Remember, a negative sign for an angle goes in the opposite direction, so it goes downward first. So sine of 30 would be 1/2, but it's in quadrant 3, so it's a negative. And so keep that in mind for that scenario. Okay, the next thing we need to talk about is your calculator. So this just says find sine of 0.8. Notice that this is not in a degree format because there's no degree symbol. So you got to make sure in your calculator now you're in the right mode for the rest of the semester. So if there's no degree symbol like this, you need to make sure your mode is radians. So there should be a spot where you can click mode and it should be either degree or radian. You need to be in radian mode. And then you need to try these 3 questions out to make sure you're getting the right answer. Probably more important for these other 2 because they're not sine, cosine, tangent. But realize if they're cotangent, secant, you got to do 1 divided by tangent or 1 divided by cosine of the angle. Make sure you check these out and see if you get the right answer. And your calculator has got to be in radian mode if there's no degree symbol now for these questions for trigonometry. Next is find answers from the interval 0 to pi over 2. This is a giveaway that you need to be in radian mode. Otherwise, it would say 0 to 90 like it did in the last chapter. And the rules are the same. You just got to make sure in the right mode. So cosine inverse of 0.72, and you'll get this 0.767. Tangent, tan inverse of 4.2, and you should get this 1.337. But again, your calculator has to be in radian mode to make it work. I guess you could be in degree mode and then do times pi over 180. It'll just cut out the middle step. So make sure that you're being able to switch the modes back and forth. If it was cotangent, remember you need tangent. So to be tangent, you do its reciprocal, which is 1 over 2.75. But then the same rules apply. It's tan inverse of that fraction to find the answer. Cosecant goes with sine, but it's sine of 1 over. And then sine inverse would be that answer. And you get 0.317. Make sure you're checking these out on your own calculator to make sure you know what to plug in. Maybe write a few notes about that scenario so you know what you're looking at to be successful. The next couple questions have some specific directions. So this one says it's in the given interval, pi over 2 to pi. Pi over 2 is 90, pi is 180. So this is just saying it's from 90 to 180, which means your answer has to be in quadrant 2. All that tells you is where the reference angle needs to be drawn. So you notice here this is an exact value question. So the reference angle here is 60 because it doesn't even matter that it's negative. We know it's negative because it's in quadrant 2. The adjacent's 1 and the hypotenuse is 2. That's a 60-degree angle, which corresponds to a 60-degree reference angle. And if you go from the normal location and get rid of 60 from 180, you should get 120 degrees, which is the same as 2 pi over 3. Make sure you're able to switch those back and forth either by times pi over 180, or for exact values, 60 is pi over 3, and there's 2 of them to be in quadrant 2. 3 pi over 2 is 270, 2 pi is 360, so that means this answer is in quadrant 4. The thing I like to tell students about this question is it looks pretty confusing because it's 2 root 3 over 3, and you say, well, that's none of my side lengths. But if you flip-flop this, it's 3 over 2 root 3, rationalize the denominator by multiplying by root 3, and simplify it down, it's root 3 over 2. If it's an exact value and it has a root 3 in it, when you flip it, it still should have a root 3 in it. So it has to be root 3 over 2, which corresponds to the adjacent being root 3 this time, which has to be a 30-degree reference angle. In quadrant 4, you find that by taking 360 minus the reference angle of 30, which is 330. You can multiply by pi over 180, or 11 times 30 is 330, so it's 11 times 30, or 11 times pi over 6, because pi over 6 is the same as 30 degrees. I would still have those basic reference angles, pi over 4, pi over 3, pi over 6, pi over 2 written down somewhere from the last section, because it should help you be successful in some of these scenarios. Okay, the next question says find all the answers from 0 to 2 pi. Well, that's the same as 0 to 360, just in radian format. So what you want to look at is how do I solve them? What you could do is solve them in degree format and then kind of work backwards. So if I do it that way, I know sine's positive in 1 and 2, and I know my reference angle is 30 degrees because opposite of 30 is 1 and hypotenuse is 2. And in quadrant 1, that would correspond to a 30-degree angle. And in quadrant 2, that would be 180 minus 30, which would be 150. And then you just switch them into radians by times pi over 180, or the fact that 30 is pi over 6, and 150 is 5 times pi over 6. Exact values should work the same way, it's just your answer has to be in radian format based on the given information about 0 to 2 pi for the interval. Same idea here, 0 to 2 pi, but notice this is tangent squared. Think about it, if it was x squared equals 3, to get the squared away, you'd have to square root it. But it should be plus or minus. Remember, if it was x squared equals 9, it's x equals plus or minus 3. This is good and bad for you. The good part is you don't have to worry about what quadrant it is because there's 2 that are positive, 2 that are negative, and that's all 4 quadrants that you're looking at. The bad is you have to find 4 answers. Okay, so for this question, tangent is root 3. So that would be opposite is root 3, adjacent's 1. The reference angle is 60. And you literally find a 60-degree reference angle in all 4 quadrants, which should correspond to these 4 answers. And then switch them to radians by times pi over 180, or 60 is pi over 3, so 120 is 2 of that, 240 is 4 of that, and 300 is 5 of that pi over 3, or 5 60s. So the nice thing is you don't have to worry about where stuff is positive and negative because there's 2 for one and 2 for the other. The problem is you have to type in all 4 answers to be successful on the question, especially on your homework and assessments. The next question is just a thinking question. They're telling you what x is, so just plug it in, make sure you're in radians. So sine of 49 is negative 0.95, cosine's positive 0.3. Well, where is sine negative, cosine positive? It has to be quadrant 4. Plug in 79, you get negatives for both x and y when you plug them in, or sine and cosine. And the only spot that happens is in quadrant 3. So it's just asking, instead of having to go around the circle a bunch of times and figure out where it's at, it's saying, well, just plug in sine and cosine, and whatever the positive negatives are, that'll tell you what quadrant it's going to be in. That can save you some time, especially when you're dealing with radian format that you're not as familiar with. But you have to have your calculator in radians to find these answers. Okay, that's everything for today's lesson. Again, you could use the unit circle if you want. I'm not planning on focusing on the unit circle because it's just another memorizing tool. You already have enough memorizing pieces to look at with exact values. Make sure your calculator works the way that it should. Check your answers, and have a good day, everybody.